Imagine holding a simple magnifying glass and watching light magically change direction. Today, we'll explore how lenses bend light using a clear basic diagram that turns this invisible dance into something you can easily see. First, picture 3 straight light rays traveling from left to right like parallel arrows marching in a line. They move in a perfectly straight path because nothing is there yet to disturb or bend them. Now we place a thin convex lens in their path, drawn like a simple oval shape, thicker in the middle and thinner at the edges. This lens is made of a transparent material that slows light as it passes through. As each ray enters the lens, it bends toward an imaginary line passing through the center of the lens, called the optical axis. This bending happens because light changes speed when it enters the lens material. Inside the lens, the rays travel on new tilted paths. When they exit, they bend again, this time in the opposite direction, all steering toward a single point where they will eventually meet and cross. The point where all those rays come together is called the focal point. In our diagram, it appears as a bright, tight cluster on the optical axis, showing how the lens concentrates incoming parallel light. If we move the light source closer, the rays no longer arrive parallel and the paths change. The diagram now shows rays spreading from one side, then bending through the lens to form an image on the other side. This simple diagram reveals the secret behind glasses, microscopes, and telescopes. By bending light in predictable ways, lenses form clear images, turning straight rays into focused pictures our eyes can understand.